So this is the last lesson of the Algebra 1 review, and it's the first lesson that's being recorded for you to watch in class um, with your earbuds. And I will be around to help you out if you have any questions along the way. So let's get started. This one is about solving inequalities, in particular solving multi-step linear inequalities and practical problems involving linear inequalities. I expect that we will have a quiz, and this is not as advertised a week ago, but it's partly because of the hurricane and just partly my oversight, but we will have a quiz this Friday, Thursday and Friday. Thursday, let's see, make sure I think it's the 12th and 13th for the quiz, and the test on the 18th and 19th. So as you're going through these slides, if you need time to take notes as much as you want, then pause. If you need to hear something said again, then you can go back and listen to it again. Again, if you have any questions, something that's not clear to you, raise your hand and I'll come over and help you one-on-one. So again, this is review from Algebra 1. This first slide shows the four possibilities of an inequality. The variable could be greater than or equal to, less than or equal to. We should know at this point that this bar underneath is what makes the or equal to. We should know that when the symbol is pointing to the right, that's a greater than. If it's pointing to the left, then that's a less than. You may have some way that you remember this, like alligators, and I've heard things like that, but in the end, these symbols, you should just know what they mean. If we graph these inequalities, notice the difference. So first, the graph of a one variable inequality is a point on the number line with shading. So all the points to the right of 4 solve this inequality. The open circle on 4 means 4 itself does not solve this inequality, and that's because it's not or equal to. Right? When you add the shading to that point, that means 4 solves this and any point to the right of 4. So x is less than 4 would be open circle on 4, shaded to the left. Less than or equal to, closed circle on 4, shaded to the left. Okay, this should be a very basic review. So the properties of inequalities. Specifically, these are like, how do we solve inequalities? What are we allowed to do? How is it the same and how is it different than solving an equation? So most of the properties here are exactly the same. You can add the same thing to both sides and it does not change the inequality. Here's the example. If 4 is greater than 2, then 4 plus 1 is greater than 2 plus 1. Okay, that's certainly true. Same thing works for subtraction. Okay, where it differs is if you multiply or divide by a negative number, then you have to flip the inequality symbol. Right? That's what this bottom one here is telling you, that and that. So in this one here, we're multiplying by a constant c, but the c is less than 0, meaning it's a negative number. Right? So what's going to happen? It's going to flip the inequality. It was a is greater than b. Now it's ac is less than bc. Or look over here. 3 is greater than 2. And negative 4 is less than 0. So if I multiply both sides by negative 4, I'm going to get negative 12 on this side, and get negative 8 on that side. So you can see that 3 was greater than 2, but now negative 12 is less than negative 8. And the reason for that is simple. Right? If 0 is in the middle here, let me just put in a couple numbers. Like I'll just put in 1 and 2, right? 1 and 2. As you go away from 0, the numbers get bigger to the right, right? And they get bigger negatively to the left. So if I take 1 and 2, 1 is less than 2, but if I multiply them both by negative numbers, I get negative 2 and negative 1. But negative 2 is to the left of negative 1. So the order has been flipped. So that's why this property has to be. So other than that, solving of inequalities works the same as it does as solving equations. As long as we do the same thing to both sides, we should be okay. Right? So we need to isolate our variables by doing operations to both sides until we have the variable on one side, and with the inequality, the solution is on the other side, with the inequality symbol. All right, so here's an example, and you have to think to yourself, how do we solve equations? What do you get rid of first? This x is buried within this expression, which is inside parentheses. You want to strip away everything that's on this side with the x. If you say, well, I'm going to distribute, it's not necessarily wrong, but I think probably the smart mathematician type probably does this. Let's just subtract 1. Let's start taking away things first. So this is negative 3 times 2x minus 5. These cancel, greater than or equal to 3. Right? Notice that me subtracting 1 does not change that greater than or equal to. Okay, now what's the next thing I could peel away? Well, this negative 3 is multiplying. So if I divide by negative 3, now I got to remember to flip that sign. So if, for example, I just did this, right? Divide by negative 3, divide by negative 3. At that point, this inequality is wrong, because I have to flip that symbol the minute that I do that, which is why, for your purposes, when I'm showing this kind of thing, I'm not going to do that. Instead, I'm going to write it on a new line. I'll write negative 3 divided by negative 3, 2x minus 5. Now I'll flip the symbol, less than or equal to 3 over negative 3. Okay, these cancel. Now we have 2x minus 5 is less than or equal to negative 1. At that point, we have a two-step inequality to solve, and those two steps are add 5, divide by 2. So add 5, divide by 2. And here I can just write divide by 2, divide by 2, because it doesn't flip the symbol anyways. So x is less than or equal to 2. Okay, usually when you get an inequality to solve, it's always going to say graph the solution. So graphing the solution, ideally, I should put the 2 on there. Should probably also put a 1 and a 3, just so I get the order of things correctly. Believe it or not, sometimes, especially with the negative numbers, we get that part wrong. So less than or equal to 2 means it should be closed circle, and less than means to the left of the 2. Now for me, that should be adequate. If you can't think of this less than being to the left or greater than being to the right, when the variable is on the left here, then this inequality symbol is pointing to the direction of the shading. That's another way to keep that straight. All right, so try this one on your own. Hit pause now, and when you're done, hit play, and you'll see me work out the same problem. So hit pause now. So similarly, on this one, I probably should subtract 5 and then divide by -2, which will flip the symbol, okay? I'm going to do it differently just because some people probably instinctively don't think to do it that way. And I want to, so you can see it, it'll all work out in the end. How about at first we'll distribute instead? -2x minus 18 plus 5 is greater than or equal to 3. Combine like terms on the same side. -2x minus 13 is greater than or equal to 3. Add 13. -2x is greater than or equal to 16. Okay, at this point I'm going to divide by the negative, so I'm going to have to flip that sign. So I'll write this on a new line. -2x divided by -2 is less than or equal to 16 over -2. Right? The -2's here cancel, they just equal 1. And now we have x is less than or equal to -8. So I'm going to put in the -8. To the left of that should be -9. To the right should be -7. Oops. Should be closed circle because of the or equal to. And it's less than, which means the shading should be to the left. Okay, a movie rental company offers 2 subscription plans. You can pay $36 a month and rent as many movies as desired, or you could pay $15 a month and rent $1.50 to rent each movie. How many movies must you rent in a month for the first plan to cost less than the second plan? All right, so word problem time. The first thing I'm going to do here is just define my variable, right? What is the thing that we're trying to find the number of? And the answer is how many movies. So let's say x equals the number of movies rented. Okay, the first plan costs $36. It doesn't matter how many movies you rent, it's just $36. The second plan costs $15. That's what it costs no matter how many movies you rent, plus $1.50 for every movie that you rent. So obviously, if you don't rent any movies, it already costs you $15, and that makes the first plan more expensive. But the more movies you rent, this number is going to get bigger. And eventually, the 36 will be less than this expression on the right. They want to know how many movies X do we have to rent so that the first plan is less than the second plan. So with words, they've asked us to set up this inequality, and then we should solve this just like we did the 2 that preceded. All right, so let's subtract 15. We're going to get 21 is less than 1.5 times x. And from there, you can divide by 1.5. And what are you going to get if you could put that in the calculator to figure that out? You could think of this as 3 halves, which means like multiplying by 2/3. In any case, it's 14. 14 is less than x. Or, this is the symmetric property, x is greater than 14. So make note of the fact that the 14 was on the pointy end of that inequality symbol, And when I switch the sides of the x and the 14 is still on the pointy end of that inequality symbol. Okay, so the answer is if you rent more than 14 movies, then it's actually better for you to use the first plan. All right, did not ask for a graph. All right, try to do the same thing with this one. Again, pause, try to think it out yourself, don't give up too quickly. And when you're done, or when you're absolutely stuck and you have asked me for help and you still couldn't figure it out, hit play. A digital music service offers 2 subscription plans. The first has a $9 membership fee and charges $1 per download. The second has a $25 membership fee and charges 50 cents per download. How many songs must you download for the second plan to cost less than the first? Again, what did we do in the previous example? What was the first step? Define the variable that we're going to use in these expressions. What's the thing we're trying to find the number of? How many songs for download? So let's say that x equals number of songs downloaded. Okay, now let's make our expressions for each one, for each of the 2 plans. The first plan has a $9 membership fee. That means this is the part that doesn't change. And it charges $1 per download, so 1x, so just x. The second charge is $25 and 50 cents per download, so that'll be plus 0.50 times x. So we want to know what is x going to be so that the second plan costs less than the first. So that would make the first greater than the second. All right, well, that's a fairly easy inequality to solve. There's no combining of like terms to do on either side of the inequality. So we should try to move the smaller variable term first. And the smaller of the 2, 1x and 0.5x, is 0.5x. So let's subtract that. So now we have 9 minus 1 minus 0.5 is 0.5x. That was a plus, sorry. Is greater than 25. All right, subtract 9. Um, 0.5x is greater than 16, and then divide by 0.5. So that means x is, again, you can put this in your calculator if you need to, but that is greater than 32. So translated back into the context of the problem, you need to download more than 32 songs to make the second one a better deal for you. Okay, if you do less than 32, then you're probably better off with the first. Okay, like we did with the solving equations, it's possible that when you solve an inequality that you might get always true, means it doesn't depend on the variable, it's always true. A sometimes true, which are like the ones we've been solving up till now, or a never true. I mean, this is the language of our textbook, and there's nothing wrong with it. Probably we would say, when you solve an inequality and it's always true, that's like saying the solution is all real numbers. If you solve an inequality and it's never true, we would probably say no solution. But the book is not going to ask it that way, so we'll go along with what the book has. Okay, so let's see what happens if I try to solve this inequality. First step, distribute. Negative 6x minus 2 is greater than minus 6x plus 7. Add 6x to both sides. Okay, these cancel. Negative 2 is greater than 7. So what we've got now does not include a variable. So our original inequality is either going to be always true or never true. It doesn't depend on the variable. Is this true? And the answer is no. Negative 2 is not greater than 7. It's false. So we would say this is never true. No solution. All right, let's try this one. Distribute. Combine like terms. 10x minus 7x. Subtract 3x. Negative 15 is less than or equal to 8. Again, an inequality without a variable, so it's either always true or never true. Is negative 15 less than or equal to 8? The answer is yes. Therefore, this is, since that's true, this is always true. So the solution is all real numbers. Let me check something here. So this is for you to try. So hit pause, do it, or do it until you can't get any further, then hit play. Distribute. Subtract 8x. So this statement is true. So it's always true. So the solution is all real numbers. Which, by the way, if you had to show on a graph, you would just graph the whole number line. Okay, compound inequalities are when you have two inequalities and they're tied together with a word. The word can be and, or the word could be or. Right, so for a compound inequality to be true, it depends on the inequality. Just by the rules, if there's an and that connects them, then both parts have to be true in order for the whole compound inequality to be true. If there's an or that connects, then if only one is true, that's okay. At least one has to be true. But if you look at it in terms of just the English language, if I said, I'm going to go out to dinner and go see a movie. If I go out to dinner, but I don't go see a movie, then what I just said is false. I said I was going to do one and the other, and I only did part of it, so therefore it's wrong. Both parts would have had to have been true for that statement, which had an and in it, to be true. If I said, I'm going to go out to dinner, or I'm going to go see a movie, and I go out to dinner, then is what I said true? Sure. I didn't say I was going to do both. I said I was going to do one or the other. I did one. That makes it true. So we're using that same kind of verbal logic with these compound inequalities, purely math. So what is the solution to this compound inequality, which means this whole thing, including the word and, which is in the middle. So what do we know? If it says and, we're looking for both parts to be true. Okay. For a lot of these, the way you see that is by graphing it. You'll know what the answer is when you graph it. So let me solve this inequality. This will be minus 1, minus 1. 6 is less than 2x. Divide by 2, divide by 2. 3 is less than x, or x is greater than 3. Okay, this one. Divide 3, divide 3. X is less than or equal to 6. Okay, so now let's put both of those on a number line. So I'm going to show the 3 and I'm going to show the 6. At least relative positions, 3 goes to the left of 6. If x is greater than 3, then open circle on 3, shaded to the right. If x is less than or equal to 6, closed circle on 6, shaded to the left. Now, for the compound inequality to be true, we need to find the part of the number line where both of those inequalities are shaded in. Again, where is that? Well, it does not include 3, because 3 is not included in this one. But it starts just to the right of 3, and it goes all the way to the 6. So, this is the solution. Now, if you were going to write this with words, you would have to say the solution is x is greater than 3 and x is less than or equal to 6. If you don't write it with and in there, it's not all the way correct. I mean, out of 5 points, I'll probably take off 1. Okay, but it's not all the way correct. If you accompany just x greater than 3 and x less than or equal to 6 with a graph that clearly shows your shading of the solution, that it's not like all the way to the left and it's not all the way to the right, it's just the shaded area in between, then that's okay too. Another way you can write this is with what we call a three-part inequality, is I would go like this. 3 is less than x is less than or equal to 6. That says the whole thing. I don't need to use the word and or anything. And that's actually what real math people use. Okay, now let's look at an or. Okay, subtract 7. Subtract 8. So again, as a solution, that could be the solution right there, as long as you use the word or. If I put it on a number line, see, I need to have -1 and -5. The -5 should be to the left of -1. Greater than or equal to -1 would have been closed circle, shaded to the right. Less than -5 would have been open circle, shaded to the left. Okay, in order for the compound inequality to be true, just one has to be true, at least one. And so that would include this area on the graph and this area on the graph. So that is the graph of the solution. Just leave them like that. You're not looking for an overlap, and you cannot do a three-part inequality for something like this. Would not work. Okay, here's your you try, so hit pause, and when you're ready, hit play. I'm going to do this -3, -3, 7w is greater than 8. Divide by 7. W is greater than 8 over 7. Add 1. 4W is less than negative 12. Divide by 4. W is less than negative 3. Tied together with an OR, that's your solution. Graph it. Negative 3 goes to the left. 8 over 7 goes to the right. Greater than 8 over 7 means open circle, shade to the right. Less than negative 3 means open circle, shade to the left. And that is the graph of a compound OR. Okay, let's try our U-try compound AND. Add 1. Divide by 3. Divide by 2. Okay. That is your solution. On a number line, 2 goes to the left, 6 goes to the right. If it's greater than or equal to 2, that means closed circle, shade to the right. If it's less than 6, then it's open circle, shade to the left. Okay, since this is an AND, we're looking for where in the graph are both inequalities overlapping each other, and that would be here. Okay, so that the graph has to show that you understand that the overlap is the solution. Now, again, I can write this as a three-part inequality. Just look at here. The x goes in between those two. Since that's closed circle, it's less than or equal to. Since that's open circle, it's less than. Like I said, even better way to write a compound, a solution to a compound AND. Okay, and I guess this slide kind of just says that all together. Right? The solution to AND inequalities can be written as three-part inequalities and is preferred. When we get into the next lesson, which is the first real Algebra 2 new material, this comes up even more. Okay, you could also be asked to solve a three-part inequality, right? That looks different than anything you've seen before. Usually we look to isolate the variable on one side of an equal sign or an inequality symbol, but in this case we have two inequality symbols, and the variable is in the middle. So you try to isolate the variable in the middle by doing operations to all three parts. So how would I isolate x here? Well, I have to add 4, divide by 2. So the first step, add 4, add 4, add 4. You have to do it in all three parts. Negative 2 is less than 2x is less than 16. Divide by 2. Divide by 2. Divide by 2. Right? Negative 1 is less than x is less than 8. Now, if I graph that, negative 1 will go on the left, 8 will go on the right. Looks like both of them are open circle. And you should look at a three-part inequality that x is between the negative 1 and the 8. So we're going to shade between the negative 1 and the 8. There's not a lot of problems to practice this in our texts. That's why I've kind of assigned one problem, which comes from like the very first part of the homework problems. It's a little separate, but it's the best I could do in terms of finding that. Okay, next. So try to do this one. Hit pause, and when you're done, hit blank. So first step, add 1 or subtract 1. Okay, this is a little tricky because now we have to divide by -2. But when you divide an inequality by a negative number, what do you have to remember to do? The answer is flip the inequality symbol. So I'm going to write this on a new line. -4 over -2 is greater than -2x over -2 is greater than 6 over -2. Okay, -4 over -2 is +2. The -2's cancel. And 6 over -2 is -3. All right. Now, you could use a symmetric kind of property and rewrite that as -3 is less than x is less than 2, if you need to. Looks like both are open circle, and the shading is between. Okay, so that finishes the lesson. We solved multi-step inequalities. We did a couple practical problems. Before you do the homework, I really want you to do an exit ticket, which is part of what they have us doing. They want us to be doing this more routinely. These are actually 2 problems that come from the homework assignment. So you're actually going to be doing 2 of the homework problems. So do these 2, and when you're done, raise your hand and I'll come over and check and make sure you're on track. And then that is the full homework. So, best use of time would be, if you've got time left, you should be working on your homework, right? Do not take out cell phones.